Alright, so we've got this next one here, AS, H3 AS. There's just one of them. It's happy with 8 valence electrons. Hydrogen, there's 3 of them. They're happy with 2 valence electrons. Remember, it's got a reduced octet, 1 shell. Only happy with 2 valence electrons. So 3 times 2 is 6, plus 8 is going to give us 14 in an ideal world. AS, it's in group 15, so it has 5 valence electrons. Still 3 hydrogens, 1 valence electron here. We're going to get 8. So we're going to end up with 6 shared electrons or 3 bonds. Put our AS in the middle, hydrogen on each side, bond each of them, make the AS happy, and everything looks good. No expanded octet, no reduced octet aside from these hydrogens. For our AXE notation, it's going to be AX3E, and the shape that goes along with this is trigonal planar. We're going to count up our x's and our e's. This goes 3 plus 1 gives us a total of 4 between our x's and our e's. So we're going to use 4 orbitals, an s orbital and the 3p orbital. So this is going to be sp3. And as far as polarity goes, first question, are there lone pair electrons? There are. So the answer to that question is a resounding yes. Now let's take a look at PBr5. There is 1 phosphorus. Phosphorus would love to have 8. There are 5 bromines, and bromine would love to have 8. So that's going to give us a total of 48 valence electrons in an ideal world. There's still just 1 phosphorus. Phosphorus only has 5 valence electrons, and there are 5 bromines. I should have a little plus sign there. And 7 valence electrons for each bromine. So 35 plus 5, that's going to give us 40. 40 minus 8 is going to give us 8. Divide that by 2, 4 bonds. Oh boy, I thought we were done with these. I guess not. Alright, so we can't do 4 bonds and 5 things attached to something, so we're going to have an expanded octet, and we're going to try to get a total of 40 valence electrons here. So we're going to put our phosphorus in the middle, and put a bromine, 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 and bromine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. Make everything happy. And let's see, that gives us 5 things that have 8 valence electrons. That gives us our 40 valence electrons. We don't need any lone pairs electrons on here. So we're going to go to our AXE, and this is just going to give us AX5. And our geometry for AX5 is going to be trigonal bipyramidal. Basically, the way it looks is we've got our phosphorus in the middle, going up from the phosphorus is a bromine, going down is a bromine, in the plane of the paper is a bromine, and then going back at about a 120 degree angle from this bromine is another bromine, and coming out of, I did it again, going out of the paper is another bromine. So we've got a triangle here, and then they're going to connect up to that guy and make a little pyramid, and then we're going to have a pyramid down below. So that looks terrible right there, but trust me, it's trigonal bipyramidal. And our hybridization, we're going to need to add up to a total of 5. So one of them is going to be an S, 3P, or P3, just D. So that's where our hybridization will be. And then for our polarity, if we go through the questions that are in our notes, there are no lone pair electrons. All the terminal atoms are the same, so this would be non-polar. And looks like I only have about 15 or 45 seconds left to do this last one, so I'll go to the next part. So we're going to stay tuned for part 4.